Hello, everybody. Welcome to the Freedom of Conversation podcast. Today, I will be talking about programming with my friend David Gregg. And if you missed last week's episode, I was talking with Randy about alcohol. So to get us started, here's David. How's it going, man?
Hey, Tyler. How's it going?
Pretty good, pretty good. Anything exciting going on for you?
Well, I get to be on this podcast with you.
I don't know if that's necessarily exciting, but I appreciate it.
Thank you for having me over.
So what exactly is programming? Like, for most people, I would assume, like, I'm an accountant, right? If I walk up to somebody and say, oh, I'm an accountant, they have a general understanding of what I do. But if somebody says that they do programming, they basically understand that it's computers.
Right.
So what exactly is programming, or what would be your framework for describing it?
Yeah, I think probably the best way that I could maybe begin this is by saying that programming is written instructions to a computer that a human is supposed to read.
Okay.
So, to kind of break that apart for you a little bit, it is written instructions. So you're telling a machine, I want you to do this, I want you to do that, I want you to show this to the user, I want this button, I want you to be able to click on the button, and so on and so forth, right? But at the same time, I'm not just talking to a computer. Computer doesn't need me to write those instructions in any human readable way.
Okay.
Computers, at their core, they work off of very simple concepts. They work off of binary, which is like zeros and ones, which you see on the matrix, coming down. Sure. But then also, you could if binary is maybe a little bit of a spacey thing to think about, it's a bit like a machine works on switches. You have a switch is either on or off. It's either 1 or 0. That's it. That's all it is. At its core, machines work on that level. And in your fanciest computers, at its core, it's the same thing. It's either on or off. This little piece of circuitry is on or off. That's it.
Okay.
And then you've got different pieces of circuitry that are responsible for different tasks in the computer. But you either turn it on or you turn it off. And so the computer doesn't need me to write the instructions in any human readable way. It just needs the on or off sequence.
So essentially, to sum it up, if enough things are on or off in a given combination, that produces the outcome that you're looking for.
Right.
Hopefully.
Right. So then in software development and programming, our task is not just to write software that works. Our task is to write software that other developers can read, or that I can read in 2 weeks' time when I forgot what the heck I was doing.
Gotcha.
And so software development, programming, coding, software engineering, whatever you want to call it, it's a bit of a science and an art, because you're writing software to the very precise requirements of a machine. That's like where a lot of the science comes in, but also you're writing something which is meant to be expressive to other developers or yourself later down the road in a way that saves them time. Because in software development, most software development jobs, developers will say that they actually spend more of their face time with code, they spend reading code than writing code.
Okay.
So it's also the biggest opportunity for saving time.
Right.
If we write readable code that is pretty self-explanatory, then we're saving ourselves time when we try to get back into it later down the road. When we try to fix it, we don't have to struggle with the concepts in the code for a week to just try to understand what it's even doing. If we can read it and go, okay, these are the instructions that the computer has, that's where the logical flaw is, then we can fix it, and it hopefully would take 30 minutes to do that, or whatever the case may be.
And this is all before you even really technically see the end result. So for example, I'm using like this software that we're using to record right now. Somebody obviously had to program that when these things happen, it captures this, and then it saves it, whatever, right? So you're talking about before we even see like what's on the screen right now, you're talking about reading just to make sure that even has a chance of happening.
Well, to a certain extent, but you have to remember that everything is like, we're building things in pieces.
Right.
And there's also this concept of like a minimum viable product. Are you familiar with that term from like certain parts of the business world?
Not particularly in the like sense that you're trying to use it. Like, yeah, I'm having a hard time wrapping my head around.
It's
what
probably
you mean.
not super common in the finance world, but a minimum viable product is like where you have product creators, like software developers, for example, creating something. A minimum viable product is like what's the simplest version of this we can provide that just gives us that we can ship to our client, to our customer, or whatever, so that we can get them to use it to a little extent, so that we can get some feedback on it. Okay. So we can learn something about it, so that the next version will be even better than it could have been if we just went ahead and made the new version.
Got you.
So then a minimum viable product is like, what's the minimum that I can get working? And so like with software, you're never writing from scratch like all this code for a complex piece of software without running it, without trying little pieces of it a piece at a time. What you do instead is you get the minimum up and then you see it run. Does that run? Okay, no, it doesn't. I've got this I need to fix, I've got that I need to fix. I'm getting some error messages. Your programming languages will give you error messages, and then that will give you clues in order to track down where your problem is. And then I overcome that challenge, and then there it is. There's my minimum viable product. Okay, that's running, that's working. Okay, now I can move on to the next little step. And you just build it incrementally like that.
I got you. So it's almost like building a pyramid where your base is like the absolute bare minimum, and then you add a little bit, and then you add a little bit until you reach the point that is the final product.
Right. Okay. Although I might bring us more into the modern age, so you can imagine in like modern construction. If you go into, I don't know if you've in the last, 20 years been at all involved in any sort of like actual home or building construction project. But
I was actually an accountant for a general contractor for a year and a half, so I'm super familiar with that.
Right. So then oftentimes though there will be pre-built portions of not maybe a whole room or anything like on a grand scale like that, but you might have certain elements of a building that already come pre-built.
Oh yeah.
And so no one really pours and compresses drywall in the building where you're going to pull it up. You're going to pull some drywall in off of a truck, and you're going to put it up. So someone's already put that together for you. You don't have to do the nitty gritty. Same thing in software. There's a lot of things that are already built for you by other software developers because these are basic wheels. You're not going to reinvent that wheel all the time. You're not going to reinvent how to do a button. Buttons have been done. They're a known problem.
Okay, that makes a lot more sense then, because I think especially with people that don't get into it early or like older generations, it almost seems like you're starting from scratch every time, when in reality you're more likely taking a jigsaw puzzle, piecing it together, and adding more pieces that are your own. In a way, I guess that's kind of how I put it together, because I don't know anything about programming. Like I said, I went to school for accounting. I know finance. I know the programs that I use for finance, but when it comes to putting any of that together, I'm very technologically impaired. And it's probably an embarrassing thing to say for a 25-year-old that grew up with technology, but it was just, I never really cared how it was made.
Sure.
I always was just glad that it worked. And up until basically since we met a few years ago, I was never really interested in that kind of stuff. But I mean, hell, it seems like the building of it's equally, if not more fascinating than most of the products that get spun out of the kind of thing. Yeah.
I mean, I'm fascinated by programming languages and code and the whole task, the challenge of what you're trying to do. It's like in many ways you're writing language, and in most of the tasks where we write language, that's human languages. We're writing English, we're writing Spanish, we're writing French, we're writing whatever.
Yeah.
And we have certain constructs, we have certain patterns that we follow. When we have protocols. Like when we started this conversation, there was a protocol that you had laid out, a way to start this program and the way to start the conversation, and there'll be something at the end. And same thing when you say hello to people, you have a protocol, you have an approach, which is itself almost a sort of language. This is the way we expect to communicate.
Okay.
Right. And so programming languages are very similar than that to that. You have, you're speaking to a computer that's expecting to hear things in a certain way, and you just have to frame it that way. But within those constraints, you have freedom. There are a multitude of ways to solve different problems.
Right.
And so you get expressiveness, much like you could be tasked with the challenge of writing a paper on bass fishing. And one person could write it one way and another person could write that and approach that same problem in a completely different way.
And each have a solution that's valid.
Exactly.
Yeah.
So in software development, I find programming is a really creative task. If you might go to it thinking that this is only like science heads and math heads. I'm not a math head, right?
Right.
I'm a language guy,
Mm-hmm.
and I find the expressiveness really interesting, where I can express my creativity, and there's an art in it, and an art of even making it readable and friendly for someone else to read it. One of my personal challenges is I like writing my code so that a brand new programmer can read it.
Okay.
That's a challenge.
Right.
A brand new programmer cannot write code that a brand new programmer can read.
Okay.
Right? It takes a more experienced person who can get into the nuance of like the suggestibility of the language and the words and how they can work together to express those ideas.
Right. So you almost want to create a universality to it, kind of thing, to where you're breaking it down to where no matter what level you are, you have an understanding of what's going on.
Hopefully. Now, not every task can you achieve that.
Right. But that's the goal.
That's the goal for me. And now I usually spend most of my time in web development.
Okay.
But if you're working on, like for example, the software that's in, for your listeners, they can't see, there's a television on the wall. It's a smart TV.
Mm-hmm.
That TV has a computer inside of it, and there's software that's written for that computer. And that TV likely has very narrow constraints. It has very poor performance, probably compared to a normal computer. You can pick up a laptop and you can play a big video game on it, and you're not going to maybe feel a lot of lag. You can run all 30 of your browser tabs open at the same time while you've got Spotify running and Twitch or whatever else going on in the background, and it's all running fine. But the TV has much less in way of resources.
Right, because it's essentially just displaying the image behind all the actual hard work that the computer's doing.
Right, but also if they can reduce the resources that TV uses. So by resources, I'm talking about like storage space, and then what we call RAM memory, which is short-term storage. It's like your short-term memory. And the processing power and things like that. Like if you can reduce the resource requirements for those things, then your TVs become less expensive to produce. Mm-hmm. And so hardware manufacturers are all about that, right? But the problem is when you have tight resource constraints like that, we're only going to allow them a certain amount of memory. We're only going to allow them a certain amount of processor. Okay, well, if you have that kind of restraint, you can't just write any software.
Okay.
You don't have complete freedom. You have to write things in a performance optimized way. You have to say, I have to write this without any wasted resource whatsoever. And when you do that, your code usually ends up not being super readable. You sacrifice human readability for efficiency. And so in some applications, like in hardware or in gaming, for example, those are two big notable examples. Mm-hmm. In those worlds, you usually end up sacrificing readability for efficiency. Whereas in certain other computer worlds, like web development, for example, you can afford to sacrifice efficiency in favor of readability. And what you're getting there is ultimately developer efficiency versus application efficiency. The developer or the person's working on that code can work faster because they can read it better, reason about it better, and so forth.
Gotcha.
Whereas in the application world, in some cases, we need to sacrifice that in the favor of application performance.
Okay, yeah, that all makes sense. Like, it basically, in my head, it's a reasoning, like, I get efficiency, right? Mm-hmm. Like, if I'm plugging away on charts all day, or like I'm going through spreadsheets and stuff, if I'm the one that put the spreadsheet together and it works, it's obviously much faster for me to look at that than somebody from the outside looking in trying to do the exact same thing, just going off what I'm doing. Mm-hmm. So I guess my confusion, or not necessarily my confusion, but why are there multiple different languages? So to me, I've never quite understood that. If something works, why wouldn't everybody use that same format? Are there languages that are better? Like, I guess I just don't understand the concept of having multiple if you're achieving necessarily the same thing.
Right. So a brief historical jaunt.
Oh yeah, go for it.
Very brief. I'm not even going to go into any real detail. But in the old days, there used to be different programming languages because you just needed a different language for a different machine.
Oh, okay.
Because
gotcha.
Every machine in those days was unique, unless they were all created on the same assembly line, the same parts, the same model and everything. IBM produced their machine, and Tandy produced their machine, and Apple produced their machine, or whatever the case may be.
Okay.
And on a certain level, you needed a unique language that was built specifically for that machine. So that's part of the history of it. We're no longer in those days for the most part. There's some truth to it, in the low level even today, in like hardware devices that we use, but that's part of it where we kind of came from. But then, we have to remember that these languages are created for tasks. And so at one point, a language is created with a specific task in mind for a specific company, probably, with specific requirements in terms of performance requirements and readability requirements and features. But then, time moves on a little bit and you run into a new business case that no one ever thought of. Like, for example, mobile phones.
Right. Oh, I'm sure that was a fiasco when that was becoming a thing.
Yeah. So, when new things come around, you often find, what we have doesn't quite meet all of our requirements. But it's not even just about that. It's like, the tooling that you want to use, the tools that you want to use to write, for example, an operating system like Windows or Mac OS or Linux.
Okay.
Those are going to be different than the tools you want to use to write a web page.
Okay, so it's more along the lines of fitting the language with, like, the equipment that needs it, or at least that's what you said it used to be.
That's the way it used to be.
So now
it's more about the task.
Okay, gotcha. Yeah. So certain languages are better for doing certain things.
Absolutely.
Okay.
Yeah.
Okay, that makes more sense.
I'm stretching the definition of the word programming language a little bit, but let's maybe broaden it and say computer language instead of programming language. But so, for example, in web development, there are the three most basic languages are JavaScript, HTML, and CSS.
Okay.
HTML is what we call a markup language. And do you remember in high school or college getting papers and seeing the teacher grade it, and then they had these fancy marks on the paper that like symbolize like this period shouldn't be here.
Oh, yes.
Or this S, there needs to be an S here or whatever. So there was like a special system that teachers have for marking up a paper. And that's
I was super familiar with it because mine were a nightmare.
I'll bet. So those are called proofreaders marks, and that's an example of a markup language, but just not one that computers use. So what a markup language is it's a way to annotate a document. It's a way to add, you might say, commentary about the document on top of the document without interfering with the actual content of the document. Does that make sense?
Yeah. So it's basically an adage.
Yeah. It's something you're adding on to it. And so that's a markup language. And HTML is a markup language. It's a way to add extra content. So an example of content in HTML would be like a Wikipedia article. Wikipedia article, you get all that whole article right there. Mm-hmm. Well, I want to present that to the world. But I don't want to just put the text on the page. I want this citation to be a link to another document. And I want this bit of text to be a heading, bold print, and I also want it to be clickable there. And I want maybe a line right under it. And I want, this to be a paragraph, not just a blob of text and then another blob of text. I want there to be spaces in between. And here's a table of contents over here, right? Mm-hmm. So HTML is about how do I take a document of text like a Wikipedia article and add extra information to it to provide structure to that content. and basically annotations for the linking and so forth, so I can jump to another document or another web page when I click on it. And so that's HTML. Okay. Very focused on that task.
I would say that's probably the one that most people would be familiar with, just from what they experience when they get on a computer, even if they don't realize it.
Yeah, probably.
That's probably the one that just shouts to most people.
Yeah, with the possible exception being formulas in Excel, which isn't really its own language per se, but you could say it that way. And then CSS is short for cascading style sheets, and it means basically what it does is it's a language that's very focused on how do you take an HTML document and add style to it.
So you said an HTML was, what was the term that you used?
It's a markup language.
A markup. So is this CSS also a markup?
No.
Okay.
It's a style sheet language, or a style language, you might say. And its whole job is to say what parts of the markup language, what parts of the HTML document should have this style, this border, this color, this animation, this amount of spacing, this font size.
So I'm having a hard time in my head at the moment distinguishing the two. So basically the markup is taking just the raw information and getting you to like some kind of portal to like a reference, or basically outward structure, where you said CSS is more of changing internal things. Is that kind of?
It's basically taking you might say that the HTML document is the skeleton of the content.
Okay.
So here's the bones, the structure, with the content all in it.
Okay.
And then the CSS is how do we add some skin, some flesh to that, some hair, and how do we add some clothing to that and make it nice and friendly and comfortable.
Cool.
But then JavaScript is the third and other piece, and that's where you get the life. JavaScript is where most of the interactivity comes from.
Okay.
And so that's the one of the three that's considered a real programming language, rather than just another kind of computer language. And by programming, what we mean is that we're actually now giving definite instructions to a computer. I want you to do this task this many times, and then after you do that, I want you to get this piece of information from the email form that the user filled out, and then I want you to do this with it. And you know what I'm saying? So like it's behavior.
Right, and those are all technically different languages.
They are very different languages.
So would I be correct in saying that whenever you look at a website, you're not just looking at one language? You're inevitably,
most likely not.
Yeah, you're inevitably looking at multiple languages that come together to create what you're looking at.
Exactly, because they have their own niches. They're very good at specific tasks, and if you have you can always have one language that's good at all, that can do all of it in a satisfactory way.
But that sounds extremely complicated.
It will often be. It could be complicated, but it also, if it's trying to do too many things, it's likely not to do any one of them especially well.
Gotcha, like a jack of all trades kind of thing.
Yeah.
Okay, so how, if they're completely different languages, what is, and I don't know if this is a simple question or what, but what is the thing that allows them to communicate? So why do they all work together if they're technically different languages?
Right. So that's about what's running this code.
Okay.
So in the world of web development, which is what we're talking about, because we were just talking about HTML, CSS, and JavaScript, which are the three languages in the browser, it's the browser running that code.
Okay.
So the browser knows how to read all three and knows how to put them together.
Oh, so you're basically putting them in something that meshes them together.
Yeah.
Kind of. Oh, okay. That makes a lot more sense then.
And you're also sort of bundling it all up together. So when you say go to xkcd.com right now, what is actually happening when you type that in, and by the way, shout out to my favorite webcomic online. You type that in, xkcd.com. Mm-hmm. What actually happens is the browser starts a protocol. Remember, we talked about, like, we started a conversation at the beginning, and there's a specific way and format you want to have that, and an exchange of ideas, and how's the weather, and whatever.
Yeah.
Same thing with computers. What happens when you go to xkcd.com? The browser knows what protocol to follow. It's called HTTP, and it says, hey, xkcd.com, anybody home? Is there maybe some content there that we could have access to? And then that computer, where that xkcd.com server lives, that other computer out there on the internet, it says, oh, hey, yeah, I hear you. I can give you some content. Here's a response. And it'll give the browser that HTML file.
Okay.
That HTML file includes, in addition to the actual text, it'll include a link to the image for that day's webcomic, the image of the logo. It'll also include a CSS file for all the styling and the colors of that website and the font that they use and the bold print and the fine print and everything. And then also a JavaScript file for any extra behavior that they've got in there. And so that HTML file actually tells the browser what JavaScript file or files do I want the browser to run, and what CSS files for styling do I want the browser to run that go along with this document. So they all basically are bundled together, you might say linked in the HTML document, and the browser just knows how to read that and then goes and gets that image, that JavaScript file, that CSS file, that font file, and then loads it all up for the user, and the user doesn't have to think about any of that process.
Gotcha. That makes so much more sense than if you really have no clue. Because we've been talking for almost a half an hour, and I've already learned more stuff about this or just the functionality of it than in the past 25 years of my life. And that's mostly because I've never looked into it, like you take it for granted.
Also, to be fair, I'm a professional educator. I teach beginners this exact topic.
Right, which I can't tell you how much I appreciate, because I feel like we take it for, like you get on your phone, you open Twitter or you open Facebook or whatever you do. There's thousands, right? You don't care what it went into to get that stuff. You just want to do what you want to do. So I'm guessing a lot of people just don't even remotely understand how that works as long as it works. They just get mad and call the person that's supposed to fix it,
Right.
So it's really cool to know that it's not just, oh man, they messed up one thing. It could literally be any combination of any amount of crazy stuff that go into just the simple thing that you're looking at for a scroll of text and stuff.
Yeah.
For what is a website.
Yeah. And in fact, I hesitate to bring this up because I don't want to discourage anybody from getting into software development, because I'm gonna say this and then someone's gonna go, oh God, I don't want to do that if some random things can happen like that. So don't take me super seriously if you're listening to the sound of my voice, but it is true. It's rare-ish, depending upon certain conditions, but it's actually possible for radiation from space to cause a momentary, unreproducible bug or crash on your computer.
Okay, that sounds just terrifying, kind of.
It happens. It's actually the reason why, for example, military computing equipment has certain requirements. If they are very important pieces of equipment, they have special shielding deliberately to block cosmic radiation.
They just wrap that shit in lead, like
something like that.
What do they do?
Yeah, something like I the details of it I couldn't tell you, but same thing with so it's less of a problem with you, for you and me with a laptop or two, in the house, but imagine Google's servers,
right?
And
it could be
Apple servers and
catastrophic.
Well, so it maybe, but the bigger idea that I want to talk to you about is that it's a rare event that it would ever happen to me or you in our lifetime.
Okay.
But with all the millions of computers
it's
running
bound to happen
with Amazon, in Amazon server rooms or whatever, it happens actually on a quantifiable level. We know there's a certain percentage where it will happen.
Oh, because it's
every
obviously
year.
We've detected it and we've seen it.
Yeah.
Okay.
Yeah, it happens and it causes who knows what. It's going to randomly flip a bit, flip a 0 to a 1 or a 1 to a 0 somewhere. And you can't anticipate it. So where we have, evolved to is basically, that's why we have redundancy. You don't just have one computer that controls this one thing.
Okay.
Because if you do, any one thing that takes that computer down takes your entire system down. You don't have any fallback. That's not cool. right? Telephone systems are supposed to work on fallbacks too. You need a way to fall back so that the whole system doesn't crash all the time.
So I guess, so when you say that like the radiation can cause a bug, are you talking about a bug that somebody can go in and technically find and fix? Or are you talking about like, oh, this one's messed up, we got to try again?
It's usually anything that you really have to recover from.
Okay.
It's usually a minor corruption, you know. It might cause something like a reboot or, you know, a piece of hardware to fail temporarily. But that's, like I said, why we have redundancy. It's why we have backups.
Okay.
And so, for the most part, companies handle it that way. The military has to take extra precautions because their equipment handles things like, you know, the missiles that are pointing at everyone.
Right. Yeah, which,
you know,
some would argue is kind of important.
I brought all that up just to, you know, to bring up an interesting, you know, point.
Yeah.
But you know, as a daily software developer, I've never had to worry about that. As before a software developer, I worked in IT for a long time. I never had to worry about that.
You ever had a student that's like, I tried to do my homework, but the radiation just fucked me up?
Well, you never know. That's the thing, is you never know. You never, you know, I may have encountered it.
Yeah.
You know, I maybe in my lifetime I've encountered it, you know, more than the average person. I don't know. But, you know, something went wrong. I rebooted it, and then now it's working fine. That's like the end of the story for me. I don't have to like know exactly the reason why, as long as it's not a recurring issue.
I got you.
You know, it's one of the reasons why I back up my stuff. And also because if my house burns and my laptop is stuck inside, I can get my data because I can buy another laptop, and I can download my data because I backed it up online.
Right. Yeah.
Yeah.
So now that we've covered some of like the more basic technical things about it, how exactly did you get involved with programming? Because you mentioned that you're an educator.
Sure.
So what, and you don't have to do like a deep dive on like everything about you, but like if somebody's listening to this and they're like, man, I never really thought of programming this way, like this seems pretty cool. What routes would you recommend they go down? What kind of got you interested? What's kind of some of that stuff?
Sure. So I'm gonna skip. We're probably gonna have, you know, other episodes where we're gonna talk about other areas of my life or whatever.
For sure.
So I'm gonna skip over some major things. But
yeah, I mean, essentially everybody that's gonna be in these first like 6 or 7 episodes are my closest friends and family. So you guys are, as long as you want to, are absolutely gonna be recurring guests.
Yeah, sure. And I thank you for that.
Yeah, because I mean, this is basically like stuff. Every episode is basically stuff that we would be talking about anyway. We just decided to record it to see if other people were interested.
Yeah.
So like, it's so much fun, like just to be able to do this kind of thing.
Oh yeah.
Like I said, it's been like 33 minutes, and I've learned so much that I never would have figured out on my own.
I think you'd be impressed with how quickly you'd be able to pick up certain things. You know.
I think you're giving me too much credit.
I think, for example, HTML isn't even a programming language. It's so simple. You can just look at it and probably make accurate guesses as to what.
Yeah, but I'm kind of simple too.
Well, I'm not going to argue with it.
But yeah, I don't know. You're giving me a lot of credit here.
No, so basically the way it started with me is I was a curious kid. I was always curious. I think that was. You know, if I ever had a superpower, that's what it was. I don't know whether it was me or whether it was the way I was raised. I could tell you that maybe part of it was the way I was raised. Like, you know, I was raised on Star Trek and nature shows.
For sure.
That's pretty much
a good combo.
You know, and I mean it when I'm talking, you know, especially with the nature shows, like, you know, Nova, and like some documentaries and like how it's done, how it's made, and all kinds of things like that. I just was fascinated by all those things.
Oh, I completely agree. Like, you know that I hunt and stuff like that. So anything to do with nature and all that kind of stuff, I'm just glued.
Yeah. And we could talk more about that background too. My father was a conservation officer. I grew up in a very interesting household, you know. Sure. But, you know, as a result of all those things, I learned, you know, wild edible plants and, you know, all kinds of fun stuff. But you know, I was very curious about the natural world and the world around me in all, you know, aspects. And I guess my parents nourished that. And at one, it started with me taking apart a telephone first.
Okay.
There was a spare telephone. I think we may have picked it up at a yard sale or something like that. Just an old rotary phone, like nothing anyone used at the time. And maybe that's how I started, and I think that was about right. Taking apart little remote control cars and fiddling with things and with batteries and electrical circuits. After that was introduced to us in elementary school, and then finally we were given. Many of my friends had computers for years, but we didn't have a lot of money, and we had a family friend who had received a hand-me-down PC from a company that no longer needed it. So basically, we ended up with a hand-me-down of a hand-me-down old computer, and it was an old. I think it was a Tandy. I don't remember what number. Computer, big tower thing, with the 5 1/4-inch floppy disks, the ones that were actually floppy.
Yeah.
The ones that you could go,
I was extremely young when I saw floppy disks and stuff.
Yeah.
But yeah, I know what you're talking about.
Yeah. And so this was an old outdated technology by the time that I was using it, but that's what I had. And it came with 2 full shoe boxes full of 5 1/4-inch floppy disks, and most of which was old business software that had no real interest to me. But I had nothing better to do, and it was a computer. Of course I'm going to look around on it.
The funny thing is the difference between me and you is you would have taken the computer, and I'd be like, "What's this business shit?" I would have been really intrigued by what their processes and stuff were for their business or whatever. I just think that's kind of fun.
Yeah, and I was more interested in how the software works, and so fiddling around with it, and when you're facing a computer with that's, if you all remember the old computers that were black screens basically, or gray or green screens, and then there's what we called a cursor. It's not exactly the same as a mouse cursor. It was a text cursor blinking at the top, and it's expecting you to type in a command. And you never know what could happen if you type just the right command.
Oh, okay.
And there was that sort of mystery to it, right? If you typed in just the right incantation, maybe you could get a really interesting spell.
Okay.
Kind of thing. You know what I mean?
I think I get it. Yeah, I've never done anything like that.
Mm-hmm.
So to me, I'm just kind of imagining the curiosity of looking in and being what is going to happen?
Yeah, so even in modern computing, there's an area of every computer that's called the terminal. Mm-hmm. Or the command line, depending on how you want to phrase the language of it, or the shell even. So all of these things you could basically use as synonyms. And so every computer has that, and it's basically this big open window where you can just type commands. There's no mouse option, there's no menus. It's just you type commands and it gives you responses. And it's a very pragmatic way of dealing with a computer, and it's a very old way of dealing with a computer. And it's still something that developers and IT professionals use every day. I use it every day. And but back before Windows and Mac OS and Linux came out, it was the only way to interact with a computer. You just had to type a command. So you had to know what commands to type it. Or at least you had to know a command that would tell you what commands were available.
Okay.
On some terminals, you could just type help.
Oh, okay, I got you. No, I think I'm piecing together what you're talking about now.
Or manual or something like that.
Because if you just type nonsense, it's not just going to spit something out at you.
I mean, you could maybe make some intelligent guesses if you know some of the language or terminology in the field. But so it started there with me tinkering around on computers and toying around with some of the software. And then eventually I got leveled up to a Windows 3.11 for workgroups computer, which was, again, a hand-me-down of a hand-me-down. Mm-hmm. And by that point, the world was already on to Windows 95 or 98 by that point.
I got you.
But I wasn't. I didn't have that. So I worked with what I had, and I started learning on that. And
honestly, it was probably a situation where doing that was almost better, because you can understand the fundamentals of what came into what was modern at the time.
Yeah, possibly.
So you understood more about the fundamentals of what's going on rather than jumping in at a later point and trying to backtrack from there.
Yeah, I can believe that. So that's basically how I got started, was tinkering around with those things. And then, one of those computers, I think it was the second one, came with it came with a piece of software called QBasic, which is built into it, which was actually a really novel invention by Microsoft for a really user-friendly, interactive software programming environment for a particular language that they built to be really simple to write for beginners, QBasic, based on an older programming language called BASIC.
Okay.
And QBasic was well known in those days by little school nerds like myself, because you would almost always find QBasic on a school computer, and if you found QBasic, you could almost always find one of 2 or 3 games built into that editor.
Okay.
That programming language editor.
Is one of them like Snake?
Yes.
Yeah, there we go.
Do you remember that? Nibbles?
Yep.
It was called Nibbles.
Okay. Now we're talking, my mojo. Like,
yeah. And then there was Gorilla.
Okay.
And I remember, and I think that there may have been another one in an obscure version of QBasic, but anyway, I remember, because you were in the QBasic editor, so you could actually not only run that program, but you could also see the programming language that somebody had written or that other people had written to make that game even work and look the way that it did.
Oh, that's cool.
How the physics worked and how the graphics worked and why the colors were the way they were. And so I got interested in tweaking it and seeing if I could hack it and make my gorilla better, or make my snake faster or whatever.
See, when I started playing because I obviously played video games at a young age, if I would have played any game that I saw the background of what was happening, I feel like I would have had the exact same instinct. Because I think it's because I never saw anything like that I never even really thought about it. But the moment a game messed up or I saw what was behind it, I would have to do some kind of deep dive to be like, what can I do to make this better?
Yeah, and so that kind of exploration ended up with me having simple solutions, like when my grandmother changed computers. She loved, I think it was Free Cell,
okay,
which was like a solitaire card game on Windows, and I think it was that game. It may have been Mahjong or something like that, but she needed to move computers, but she had won a very impressive high score that she wanted to transfer over. And then I got to looking at that program and the way that it worked, and it turns out that there was a little file in the same directory, in the same folder, where that program lived. And that file was a .ini file that actually had a very easy to read explanation of exactly what's the user who uses this, what score do they have, and maybe some other information. And so I was able to just copy that text, and on the new computer, basically I rewrote that right in there verbatim, and it just worked.
Oh, that's really cool.
Right?
I don't know most people that would think to even do that.
It's not a matter of you don't think about doing it until you just explore. You know what I'm saying? It starts out of pure curiosity. Let me go look at this file. Can I open this file in a normal text editor? Oh, I can. I can actually read what's in here. It's a little weird. There's a thing and then an equal sign and then another thing, but that kind of reminds me of algebra.
Yeah.
X equals 1. Well, in this case, instead of it being X, it is username. And then equals, and then Betty.
Right.
Right? Or high score with an underscore. High underscore score equals 1064 or
Gotcha.
Whatever.
So
right?
then you just basically plug and chug on
right.
that, and then you're good to go.
Yeah. And then those little kinds of wins for a kid make you feel like a hacker. It it gives you motivation, and it fuels your interest. And so I'm spending way too much time on this, but yeah, that's basically how I got started until finally in high school. I was at Bloomfield High School in southern Indiana, and Michelle Maddox, our school district's IT administrator, spotted me and took me under her wing.
Oh, that's really cool.
And basically crafted out a 4-credit program where I could work for her for my last 2 years of high school. So junior and senior year of high school, I worked 2 hours a day for both years. So 2 class periods a day. For 2 years, helping her as an IT intern. And during that time, she not only taught me how to build computers, but also she taught me the basics of C++ and Visual Basic, both programming languages in their own right in those days. C++ is still very common. Visual Basic, much less so today. And then from there, I ended up learning HTML, CSS, and JavaScript in high school too. We were a very small rural class. There was a graduating class of 76 students, I think. But
nice. You got me beat. I had like 54.
Yeah.
Yeah.
But despite the small size and how rural we were, we had some really good people that brought in those technologies, and I just ate it up. And then, I didn't really go directly into software development. That's a story for another time. But I did spend a lot of time in IT management, just IT stuff for a long time. But I always used some of the programming, a little bit at a time for a long time.
Okay.
So the concepts stayed with me, and I reinforced them over the years in different programming languages. And at some point, I realized that for the most part, every real programming language is similar to every other real programming language, for the most part.
For sure.
At least in terms of the popular ones that are out there. And so once you know that, and once you've learned, enough of one or two to be dangerous, you're no longer afraid of the others. So
it's probably just easier to pick up on like the patterns.
Exactly. It's because it's all about the basic patterns. They all have the same basic patterns for the most part. There's some wacky and less common exceptions out there, but for the most part, if you know how to store a piece of information in a variable, you don't have to know what the word variable means, but basically it's a little place to store a little piece of information.
Okay.
Now you know how to do that in basically every other programming language. Okay. And if you don't know exactly how to do it in another programming language,
you can figure it out.
You're one Google search away from just saying, how do I define a variable in this language?
Cool.
And loops. A loop in programming is how to do X task multiple times. Like X task, Y times, right? That's all a loop is. It's a very basic concept. How do you just do something repeatedly? Okay. That's all that is. And once you know the basics of it, you can do it in basically every programming language that's out there. And if you don't, you could very easily just go, how do I write a loop in Python? How do I write a loop in C#? Or how do I write a loop in F#, or whatever the language is?
Yeah.
And so once you learn the basic patterns, man, you're solid, especially after, I would say, your second language. Your first language is where the real learning curve happens, because you're not just learning a language, you're learning the patterns of how to think the way the computer needs you to think.
Okay.
And then the second one, you're proving to yourself that, oh yeah, this really is very similar in many ways. And it's really the third one where you really get that freedom, I feel like, most people, where you're like, okay, yeah, I don't need to so there's a certain point in a software developer's career where you realize I totally don't need to only go to a company that uses languages I know.
Oh, okay. Because you can adapt to whatever you need to know.
Exactly.
Okay, that's for sure.
Yeah. In fact,
it's funny. I actually experienced that in the last couple years of my life, because I went to school for accounting, which my view on school is probably different than most people's. Or honestly, nowadays, probably not. I don't necessarily view school as the end-all be-all of education. To me, school is more along the lines of they teach me the theories and behind it, and then once you get into the real world, you kind of learn the practicality of what you learned, right? Hmm. So when I got into my job, I'm an accountant for restaurants, right? So we use a unique accounting system that is focused solely around accounting for restaurants, whether it be inventory, whether it be sales and the cost of goods sold and spoilage of food. Mm-hmm. That's what it's focused around. So I went to school for accounting to learn all these things about, journal entries and accounts and expenses and debits and credits and all these great things. But once I got into that system, I think it's called Compete. Once you get into that system, I knew everything that it was trying to do. I just didn't know how they did it, mm-hmm. which basically sounds like what you're trying to describe with different languages and stuff.
Yeah.
Which that's pretty cool. I would love to see what went into creating our accounting system. So I might honestly do a deep dive on that like after this, because like I said, I know the fundamentals of accounting. I just don't know how they do everything behind the scenes.
Sure.
So I think that's pretty neat. And I've got that on my laptop that I could probably pick apart somehow. Or if not, I'm sure you would help me take a look at that just to see what it is. I wanted to go in because you said that you had the teacher like take you under their wing.
Yeah.
So fun fact, when I was in high school, I was a huge nerd, just like I'm sure all of our group of friends were. But instead of like picking apart computers and stuff like that, I was in like marching band and drama club, but I was in robotics. And in our robotics team, we all got fitted for what they thought we would be more inclined to be good at. And they let me pick between yeah, right. They let me pick between two because they were like, you clearly know when it comes like building stuff, because that's what I like to do, like, you know, Legos as a kid and stuff like that. I love putting things together. So they were like, we have a spot open on the building team and we have a spot open on the programming team for the robot. And at the time, just because of who I was a punk ass high schooler, right? I was like, I don't want to be that much of a nerd. I'm going to build the thing that destroys other things. That sounds way cooler. Okay. So I had a perfectly good opportunity to start learning like programming and stuff for our robot. And I was like, no, I'm good. No, that shit's dumb. And now here I am talking to you like, oh my God, that's so cool. So I missed an opportunity in high school to
it's never too late. You know, it's something that I say to my students all the time because, your audience won't know this yet, but I'm a senior instructor for Kinsey Academy. We teach people how to code. We teach people how to basically change careers into software development from whatever background that they have. And I've done that even before Kinsey. I did that for another code school that no longer exists, which was called the Iron which did a great job too in terms of their education. So I often have to talk to people who are coming into our program like, I want to do this. I've always been interested in it, but I'm not sure that I believe that I'm capable of doing it.
That's essentially where I would be.
Yeah. And so that's a common story that I hear all the time. And so one of the things that you know, is persuasive to me is if you think about like where we are in the animal kingdom, like we are unique in terms of just how well adapted we are for language. Like language is something we do, right? Like,
yeah. It's almost like humans were built for it. Because like, if you look at communication amongst any other animal, it is a drop in the bucket compared to what we've done.
Yeah, right. And so, you know, human beings, we can do programming because you might say, well, programming is got to be really foreign, right? Because programming is explaining what you want to a computer. And I would say, to a certain extent, that's true, but it's more true to say that programming is explaining what you're trying to say to a computer to someone else.
Okay.
To another human being. Because the computer doesn't need the language. The computer needs just the switches on and off. It just needs the ones and zeros.
So the computer is more of the middleman for the communication that you're portraying?
You could see it that way. It's from another angle, it's the end point, you know, but the computer is, we're going to have to write the ones and zeros one way, but what a programming language allows us to do is to write something that's closer to the way humans think, that the computer can still break down into ones and zeros when it finally needs the ones and zeros.
Okay.
So that's what actually happens, is there's this like decomposition step where it breaks down the structured thing that looks kind of English and human and breaks it down into ones and zeros. But it's in that intermediary step of the programming language form where it actually has the word while in it for looping. You know, while this is happening, do this. We actually have that. Like that's a key word in most programming languages, while, right? Function, which just means a behavior. If you want to create a behavior, if you want to create a functionality, function, right? We have these words there, and so there's a certain level of human readability there that the computer doesn't need. It's there for us to make it manageable, to make it something that we can articulate, something that we can whiteboard and we can write up, and show to somebody else. It's something that we can even talk about in conversation.
Okay.
And so, first and foremost, programming languages are human languages meant for computer digestion.
Okay, that makes sense. Yeah. Because the more like human you make it, the easier it's going to be on our end to do anything with it.
Yeah.
Yeah, that's really fascinating. So I guess another like quick segue into like schooling and stuff like that, because that's what you deal with.
Mm-hmm.
If somebody's coming in that doesn't really, like me, that didn't really understand, like, these are the aspects, this is what breaks down, this is why it's important, what would you tell them if somebody was like, okay, so if I go and I do your thing, what does that bring me when it comes to value? Like you said that you help people transition jobs and stuff like that. I don't want to ask what your sales pitch is, because that's not the right way of saying it. I'm basically just saying, like, what would you tell them is the outcome of learning what we are teaching?
Well, it's going to depend upon their goals. Not everybody comes to us with the same goals. Some people have come to us with like self-employment goals in the long run.
Okay.
Maybe not in the short term, but maybe in the long run, they want to run their own business, and maybe building some piece of software is a core part of that. I've seen that story. That's not the most common story. The most common story is, I either have known for a long time that this is what I wanted to do and this is the right step for me, or more commonly, I tried this other thing out. I tried college out, like a traditional university, or I tried, whatever job I had before. I've had everybody from, I've had several hundred students. I'm probably not quite reaching 1,000 students yet, but I've definitely over 500 students that I've personally taught, just in software development. And I've had, let's see here, one of my former students was a lawyer who just didn't like lawyering.
That makes sense. I don't know if most people would like it after a while.
Right.
Like, I'm sure there's some people that love the thrill of it, but at the same time, it's like, do I really,
I don't know.
Enjoy?
I don't know enough about it. That's my thing. Is I don't know that I know enough about it. Really.
I think I'm too much of an asshole as a lawyer. I'd just be up there trying to defend somebody, and they'd pose like their argument. I'm like, come on, really? Like, is this for real right now? Look at this dickhead. Like, of course he did it. Like, look at him.
So that's like on one extreme.
Mm-hmm.
But I've also had former incarcerated people. I've had people who had just been, stay-at-home parents for X number of years after getting out of college or high school, and were just trying to figure out how to get started in the professional world, and thought that programming or getting into tech seemed like a good industry to get into, even if they had no specific sites on programming. So the whole spectrum. It's really been impressive. Everybody from high school graduates to people who are retiring, and all different kinds of backgrounds and work experience, levels of professional experience, like from non-existent to, very experienced in professional stuff. Mm-hmm. I've had, it's incredible. But, the thing is that it's something that keeps me interested. One thing that keeps me interested in programming is that it's sort of because it's language, and language is so human, I think programming is way more accessible to most human beings than most human beings are even aware of. Like, they don't realize how accessible it is. You could totally learn this, and it's easier than learning like French.
Okay.
You know what I mean? Like, or learning Japanese, or learning, any number of other languages.
Right.
Natural human languages. Those are, in many ways, there's way more to learn, because you've got, if for no other reason, all this vocabulary to pick up. And in most programming languages, there's like a handful of, there's maybe 24 key vocabulary terms.
Yeah.
And that's being generous.
Yeah, I think just from the conversation that we've had, the thing that immediately makes me want to learn more about this, or do it, and learn about these kind of things, is the fact that we started this conversation with saying, like, oh, the reason that you would do this language is for this piece of hardware. So, like,
No, right.
As long as there's technology,
There's always going to be a job.
Yeah, there's going to
Yeah.
be programming. It's always going to be developing. You're
Right.
never going to run out of new things to learn.
Right.
Like that to me is what is most interesting.
Right.
And you could just spend forever learning it. And you're never
Well,
gonna run
exactly. So if you think about like the world of physical objects, so we have hammers, and we have axe heads, and we have planks, and we have bananas, and we have houses, and we have carriages, and all these other things, right? The world of objects. There's new novel inventions created from time to time. And when those very novel things are created, then you need new jobs. So, like, for example, with the advent of the printing press, you had an entire industry start just out of that. And then multiple industries end up ultimately breaking out of that. And so you do have these sort of like moments in history where in the world of, the creation of physical objects, you have new industries sprung. What we have in software is kind of a new universe where we could just create whatever we want.
Oh, that's true. I mean, look at video games.
Right. So you have a physical object, a computer, and leaving aside the clear differences between different types of computers. Like I'm holding up my phone right now, which is every bit as powerful as the computers that any one of us had in the 90s. Right. This phone right here, right? Way more powerful. And actually, if you're using a smartphone in your pocket, it actually uses quantum technology. I'm not even kidding. And there's some really fascinating things going on in the internals here. But so like, I'm not even talking about the differences between different computers, but let's say we have an object called a computer, but inside of that computer, we can have a not entirely imaginary world of creation where we can create spreadsheet software. Woo! And we can create any video game we can imagine.
Right.
Everything from Pac-Man to Ghost of Tsushima.
Right.
And we can...
I actually heard that game was getting a co-op mode.
It is.
So I'm might
so
be getting that game very soon.
I'm so stoked.
Because
Dude,
any
get
game
it.
with co-op, I'm down.
Love that game.
Because you've got it for PlayStation, right?
Yeah.
Okay, we might have to do a co-op run of that then.
Man, that's so good. And film we can do, and we can edit audio on there. So we can create all kinds of audio editing software. We can create ways for people to interact globally. So we have the web, and browsers as this sort of window into this whole world of communication across the, and like one thing after another, we can just create whatever we can imagine. And then for every one of those things, you have unique things to learn. Yeah. It's just kind of endless. So absolutely. Programming for me feels a lot like, in one sense, puzzles.
Okay.
And I like puzzles, not like the puzzle piece kind.
Like the what's out on my table.
Yeah,
right now.
Yeah. I've never really been interested in those personally. But like puzzles and also the elegance of writing a good essay or poem, right? Like the expressiveness. So I like all of those things. And there's also architecture involved because you have different layers of software managing different layers of meaning in program. And we haven't really touched that concept, but architecture is a real thing in software development. We actually have roles called software architects. It's usually someone who's been promoted above the usual senior developer role.
Okay. Yeah, there's just... It's hard to even fathom from somebody who hasn't ever really studied it. Like, there is really no limit as far as we can see. There's always going to be something new or something better that's going to need something else that's better, and it just builds off of this constant... It's almost like you're climbing a never-ending ladder of what this could become. And to me, that's just absolutely fascinating. Like, to me, that's why I get interested in the stuff that I do, is because when I look into it, I don't see an end to where I can stop going on it. But yeah, that's really cool. I'm trying to think of where to necessarily go from there, because we basically just covered all that. Oh, I know. So one misconception that I feel like most people have is if you walk up and somebody's like, man, I just really don't know what to do, and you're like, well, how about you like take on programming? And they're like, well, I don't really want to be in IT. And it's like, I don't want to fix computers, when really that's not what it is. So what exactly is the difference between somebody who would want to go down either one of those paths? So you said that you've gotten like all kinds of people that are like, oh, I want to make my own business.
Right.
If you want to get a programming job,
right,
is that more along the lines of like, this company is hiring me to manage their website? Is that the kind of stuff we're looking at, or?
It can be.
Okay.
So if you're getting a job as a software developer, which I highly endorse, I recommend.
Obviously.
It's a great field to be in. You're very much in demand. So in terms of the employees having the power, this is the industry to be in right now. But yeah, it's you're sorry. Repeat the question.
Oh, basically, when it comes to getting a job as a programmer, I don't necessarily understand what that means if I go in for a job interview and they're like, we need a programmer.
Okay, sure. So yeah. So usually you'll know in the job requirement,
right?
That they put up, you should have some idea of what they're wanting you to do. Usually you're not going to be the only person dealing with a website unless it's like a very small little place.
Yeah.
But that still exists, so you can still get a job as just a web developer or web designer or whatever, and you're just running the website. And so you're dealing with HTML, CSS, and JavaScript, maybe something else to support like the database side of it, so like where all the, the pearls are clutched and so forth. But so there's that side of it. But in most companies these days, you're going to have companies that produce software for themselves, or companies that produce software for other people.
Okay.
And you'll also have companies that maintain software that someone else wrote.
Yeah. In my head, I'm having a hard time conceptualizing like where I would be placed or what I would be doing other than something that's consistently developing, like if you work for Google or if you're making a video game. That's the stuff that I can think programming is a 24-hour thing that they're always working on.
Because they're always creating something.
Yeah.
But what happens if you're not creating something? So maintenance.
Yeah,
okay,
that's a great way. That's basically what I was trying to say.
Yeah, maintenance is a big deal. So for example, and here I'm going to bring you an interesting example because it's just such a, you might say that those things still exist, but military, government organizations, banking or other financial institutions, they'll often have very old computing systems that for regulatory reasons and for historical financial reasons have never been replaced and maybe cannot be replaced. So you have software that was written maybe in some cases 50 years ago or more. That was meant to handle certain things and have certain accounts, and well, what happens when the world around that technology has moved on and we no longer really use that technology? I mean, obviously that company does.
Right.
But the rest of the world does. No one starts a new project in that language anymore.
Right.
And I can think of even some local examples here in Indianapolis. Every major city has them. But so those are interesting cases because they're not people that are writing new things all the time. They're hired. They work there to maintain.
Okay.
And what that means is that there's kind of a couple of things. Sometimes you just need someone who doesn't really fix anything or doesn't need to fix something on this particular occasion, but they need to do a little research into it and they need to know the programming language in order to do it. So then they need to be able to read it. So they're there for that. But then also things just go wrong and you need somebody to be able to fix it. And what happens if, another Y2K bug comes down around? How do you... And there's another one coming up.
Really?
With the something called the Unix epoch or the Unix epoch, depending on how you pronounce it, EPOCH.
So Y2K was from my understanding of what people joke around about, it's that computers couldn't handle the change from 1999 to 2000, right? And it was going to do some kind of like crash associated around that.
And some computers did crash, and many computers were patched or fixed before they had a chance to crash. But basically, the idea came around to much of this software was written so long ago that the developers at the time had no thought of like, oh, surely they'll be using something more up to date by the time it hits the year 2000. So they never wrote in to the program the ability to roll over to the year 2000. It was always 19 something.
Okay.
Right? 1980, 1980.
Yeah.
Or 1978, 1978. It was never 2000 anything.
Gotcha.
That's where
it was the fact that they didn't program in
because
past a certain point.
Yeah, there was a naivety in those days, and there still is sometimes, where you think, oh, my company, this is just a prototype, and next month we're supposed to, now that we've proven the prototype, we're supposed to have the budget to actually write this out proper. Well, but then the company changes their mind, and the investors change their mind, and they never end up rewriting their product, and they end up saying, well, you're just going to have to just make this work. So then they never end up, revising the application or replacing it, and then you get stuck with software bugs that were never meant to exist.
Okay, I got you.
At the time of design.
Right. So what's this new one? Do I need to start building
It's very similar. It's very similar, but basically it comes down to the fact that one of the ways that programmers... So time is historically a really difficult thing. It's a known thing for humans, but reconciling different ways of dealing with time is challenging with a computer. So
I guess that makes sense because computers don't have a sense or like context of time.
No, I mean the closest we can get is like the pulses within a crystal when you send like electric charge through it or something like that.
Okay.
Like so you have what's called a processor clock, which is basically. But anyway, but yeah, so the part of the problem is that like even if you think about human beings' own concept of time, we have leap year, we have leap second.
Oh, okay.
Right?
Yeah, I get what you're saying.
And then, but more than that, we also have time zones, right?
As much as we think it's just this thing that keeps going, there's a lot of nuances to it.
There's a lot of nuance. So time zones are 1 hour apart, right?
Yeah.
Nope. Many of them, most of them probably are. But there are time zones that are 30 minutes off. There are time zones that are 15 minutes off.
You didn't have to make me look like a fool.
There.
This is my show.
No.
This is man. You just smacked me in the face.
There are time zones with some really weird rules, and then there are time zones that play by all kinds of different games. And like, for example, we got daylight savings time.
Right.
And even in the state of Indiana, we have certain small little areas, portions of counties that play by different daylight savings time rules.
Yeah.
And then, you've got to write an exception in your program to handle that specific case. Well, what if they're in this one little area of this one county in Indiana?
Right, that's true. Because like when you're traveling and stuff, you can look at your phone, and the moment you cross that threshold,
you're supposed to be able to.
Yeah.
And then, but someone's got to write that exception.
Right.
And I mean, and our just little small example of here in Indiana is repeated country after country, state after state, all over the world, and it gets even stranger. Something's going back, something going forward, on the international date line, they can actually in Samoa, there's actually a time of the year where they change the day. They just in order to sync back up with like the Australian trading and stuff. Like it gets weird with time. Yeah. Okay, so there's a lot of really interesting stuff out there already, and like in the show notes or whatever, I can share with you a YouTube video to share with your audience if you like.
Okay. Yeah, for sure.
But time is a historically difficult thing to deal with, and so one of the cheap, easy ways that we had to deal with that as programmers was January 1st, 1970 was a date that programmers just arbitrarily decided would be the date and time where we would start counting seconds. 0. January 1st, midnight, January 1st, 1970, I forget which time zone, that was 0.
Okay.
And then the next second was 1, and on up to now. And so now you can look up the Unix epoch of right now, and it's the number of seconds since that time, January 1st, 1970. And it's a way to measure time since that period of time, right?
And did they just end it like what's the conclusion that people are worried about?
The problem is that computers usually have remember, computers can only at their heart store zeros and ones.
Right.
What happens with a fraction when let's say that you take an apple and you cut it into thirds?
Yeah.
Express that in decimal for me.
Oh, it'd basically be 0.3 repeating.
How do you do repeating with zeros and ones?
That's very true.
You don't.
Right.
You can't. There's no infinity in computers. So you lose precision in numbers.
Okay.
And more than that, there's only so much storage space available for a given number.
Oh, okay.
So a programming language has been designed to store a number in this many bits. A bit is like the 0 and 1.
Uh-huh.
So in this many zeros and ones, we can store this large number representing the seconds since January 1st of 1970. But then the problem is that there's a storage limit to that. And if we get to too many seconds, we're going to eventually hit that storage limit. And now all of a sudden, all of our timestamps that were based
all messed up
are going to So that's where that comes down to.
So when are they expecting that
I don't remember
to
what
happen? Oh, okay, cool. Yeah, because I've never heard of this before. That is really interesting, though. Like, I was, in the year 2000, I was 5 years old. So I have zero concept of, like, what the hysteria was around that time. But from what I've told and jokes that my parents talked about, people that they knew that were, like, freaking out. Like, they were preparing for it.
Yep.
Like, it was going to be this huge event. Like, it's astounding to me.
Yeah.
Cause,
I remember those days because I remember I was one of the people, because I was an IT intern for my school district, which I mentioned. And so she had me going around, installing fixes for Y2K on computers in the school district. And I ran my fix on my local computer in my home.
So obviously you just said that you went around and did fixes for it, right? If that was a thing, why were so many people freaking out? Did they just think that it was impossible to fix all of it? So because of that, it would all come crashing down?
Well, it was an unknown. Like, nothing like that had ever happened before. And unless we make a big stink about it, how many companies are going to be motivated enough to give their developers the time in terms of, like, leeway time in their deadlines to be able to get around to fixing the problems?
Gotcha. Okay.
So and then, like, also, what computer aren't we thinking about? You know what I'm saying? Like, what computer has been running for 40 years in Liberty Mutual or
right
in
somewhere
the IRS database or whatever, that just no one thinks about and no one's going to think about, and then what if it just crashes,
right?
Or the electrical grid or any number of other things. So there was so much unknown about it, and then also we had to make a stink about it because people, weren't listening to the developers.
Okay, that makes a lot more sense then. Because to me, you just said that you were fixing things. I just didn't understand, like, okay, so there's a fix. What's the issue?
Yeah, so a lot of people are going to look at situations like that and think, well, clearly there was no issue. Otherwise, there would have been an issue. But there was no issue because we dealt with it.
See, the funny thing is like, I can see the rationale behind getting freaked out about that way more than any doomsday thing from, like, any jokes. Like, what was it, 2012 or whatever? Like, that got a whole movie. Like,
that amounts to superstition,
right? But to me, freaking out about Y2K makes way more logical sense than the people that are like, the Mayan calendar's ending, or guess what? It's the third Tuesday of the second millennia, and it's like 4:00, and I had like a cup of coffee this morning, and all those stars kind of align up that we're gonna blow up soon. I'm like, okay, bud, let's calm down. But is there anything that you want to bring up or talk about?
Oh, shoot.
Because we've covered a lot of ground, which for me is a lot of surface level stuff because I'm as amateur as it gets when it comes to this. But I just didn't know if there was anything that we've talked about that you kind of want to dive deeper on, or.
Well, I don't know. I tell you what. I'll tell you a little bit more about what I do. So I'm an educator, and I always have been.
Yeah.
In one way, shape, or form in my life, I've always gone that direction. I'm not even sure if it was always deliberate. It just was always there. And it wasn't always code, right? That's a relatively new thing for me. But I've always been in mentoring relationships and educational roles of various levels, even conferences and things. And so for me, teaching code was just such a perfect combination of my favorite things.
Okay.
I love helping people understand things. I love just helping people get things. I love seeing those aha moments. And then I love code, and I love the puzzle, and I love the art of it. And, I'm curious, and I always want to learn the new thing and the next thing, and the new approach and the new pattern or the old pattern, and and compare them and understand them, and what are the pros and cons and the different use cases, and why would you use this and why would you use that, and so that's always where I've been and where I want to go. And I've been in this role now for 3 years at Kinsey, and I've had, this is the biggest opportunity in my life in terms of this is the most condensed teaching that I've done ever. Hundreds of students. I just graduated about 150 students last week. Those were my students, and helped them through from zero all the way through 6 months. 6 months together. Right there with them when they are doubting themselves about halfway through CSS, at the beginning, and then realizing that, okay, I can maybe do a little bit of this a couple weeks later, and then doubting themselves again, and then, questioning whether or not they're in the right place, and then, pulling through, and then,
right.
And then getting to the end of a project and stepping back and going, oh, wow, I did that, that's my favorite thing, and that's what I'm about, right? That's sure. What I'm about. And along the way, I get to have all these fun discussions about the Unix epic and the Y2K bug and all kinds of little things that are quirks of human history and interesting challenges for us to face. And I just feel privileged to see other people start taking on these interesting challenges and adding their own voice to the conversation and getting involved with their own, fixes and their own mistakes, and then learning from that and then bouncing back. And for me, software development is has the potential to be one of the most wholesome industries. Okay. Because in order to succeed, you have to face and admit your failures. You're going to mistype something and it's going to crash, and you're going to make little flaws and bugs in your software. And you can't succeed if you refuse to face them, if you refuse to admit them. And you also can't succeed well if you refuse the uncertainty of software design. If you think that it's all there's one way to do it right, that's not true.
Right.
You're going to be, setting yourself up to learn a hard lesson if you approach things that way. So I think it's a very holistic discipline that forces us to realize that our failures are parts of a larger learning process. And every time I face an error message on the screen, that error message I accept as data about my problem.
Okay.
Not as a personal flaw, right. Not as a criticism. It's information about the challenge. And the more information I have about it, the more prepared I will be to fix it, and the more prepared I will be the next time I write software along the same vein.
Okay.
So, I just find that I find that's a growth mentality versus a fixed mentality. And there's some really great stuff out there on that topic as well, just on the psychological perspective. But, a growth mentality is something that I've found there's a lot of people in the software development industry that are right there. It's about the growth mindset, not the fixed mindset, not I'll never change, or you're either born with it or you're not. It's no, you'll get there. Let's just learn this together and let's overcome it and learn what we can and move on, and do something different next and learn from that and move on. And I think that is to me that's heartwarming for me. I get to see that day in and day out, and not every industry has the privilege of that, and I really wish that they did. But in software design, the problems are so diverse and the pacing is so fast that we can't afford to mask our errors, in clever charts and in job titles.
Oh,
and,
I got you. Yeah.
You know what I mean?
A lot of that fluff is taken out.
We have to just admit it. Okay, hey, I don't know how to solve this problem, you other developer. Why don't you sit with me and let's talk this out and whiteboard it or something, and let's figure it out. Can you help me with that?
Right.
That's a daily thing that developers do.
Right.
Planning ahead, something that we daily have to do. No barging in, and just charging in and writing software. And that's something that all developers should be doing. And I just take a lot from that. I know not every developer does it. I know not every team does it. And there are bad examples in every community.
Oh yeah.
There obviously are. And there are, plenty of people with bandwagons, and waving flags about this technology, that technology, and all of that exists too. But at the end of the day, I find way more people in this industry who look across the table and see somebody else working on another technology, and they may go, "Hey, I'd never work with that," but they don't denigrate somebody else for working with that.
Right.
Somebody else, let them work in that old database. And yes, it was called Adabase. That's still running the bank, after 60 years.
Okay.
And let them work in that because they're making buku bucks because no one else knows that language anymore, or whatever the case may be.
Yeah, that level of hyper specialization has to be crazy.
Yeah, and then let this other person work on this new cutting edge thing. They're trying to figure things out. They're trying to solve some problems. You may not understand their problems, depending on where you are, but that's cool. So so I'm a big fan of that, and so if you want to come into software development, whoever you are out there, don't just get into it because you need the cash or you think tech is a safe industry or whatever the case may be. Try to find something that interests you. I mean, it's not a requirement. I know people who they need a job and they and that's fine. That's fine. If that's you. And you are okay with programming, but it's not necessarily your favorite thing. You're not going to be doing it on the weekends or, as a hobby. That's cool. That's fine. No judgment. But try to find something that you enjoy.
For sure.
And try to find your niche and try to find the wholesomeness that's there, and lean into that and embrace it, because I think that a lot of what the software development community can offer is actually some really positive directions, in terms of the way that we deal with ourselves and how we deal with our own uncertainties and our own failures.
Nice. No, it's really great to hear you talk about this because it is extremely clear just listening to you here. And obviously I'm hoping that everybody listening gets it, that you are very passionate about this. And knowing that you're doing something that you're passionate about, just as a close friend of yours, that makes me happy, and that's what you want from everybody, you don't want to go up to somebody and be like, "Hey, how was your day?" And they're like, "Oh, work was just," how work is,
right.
What people do that.
Yeah.
How many millions of people are in that rut?
Right.
And just, as your friend, it makes me extraordinarily happy to hear that that's the situation that you're in. Because the funny thing is, and if my boss hears this off chance, it's not like I'm passionate about accounting, it's not like I wake up in the morning and I'm just like, woo, man, these spreadsheets are the bomb, right? So I definitely went into accounting with the mindset of I need a job. But at the point that I did get my job and I'm settled in like what I feel is a suitable career for me, I'm doing this podcast. I'm using that job to do what I'm passionate about.
Yeah.
Like, you saw my first stand-up set that I ever did. Like, I adore that. That is my field of what brings me joy. And I'm really glad that you found that with like your job.
Yeah.
So even if you don't have something that is necessarily your passion when it comes to your job, you should always strive to do something that can provide for that passion.
Yeah.
And it's really cool. Yeah.
Yeah.
And it's just really cool that either route you go down, there's always options.
Yeah.
And I'm hoping, like,
and if you don't have the time to make a hobby your passion, or don't have the privilege of making a job your passion, at least make your family your passion.
Exactly. Yeah. Find something that you can delve into that basically you can be proud of to a certain degree of, like, I enjoy this. I can look at this. I can point at it and be like, damn it, that is mine. You know? And I feel like so many people are missing that nowadays. And it's a good breath of fresh air to just have this conversation, because that's the essence of what I kind of want to do with this show, is like every episode's a different topic. And even if one person at some point is like, you know, I listened to that episode, or like say, hey, that episode you did with David, I looked into it. I'm now pursuing and seeing if this is something that I like to do. To me, that's amazing. Even if like one person pursues something or learns something new that they didn't quite think of in the past, I will consider like everything a success, you know? Because like this is exactly what I want to capture with this show. And I really appreciate you bringing up stuff like this, because I think it's fantastic. And I can't tell you how much I appreciate that.
Well, it's my pleasure. And I'm sure we've got some other things in tech we can talk about, even in addition to all the things outside of tech.
Oh, yeah,
I'd be happy
for
to
sure.
come back.
Oh, absolutely. And we're definitely going to be doing this again. I mean, hell, we could have recorded 2 episodes before we even started recording with all the crazy shit that we were talking about.
That's true.
Is there any like final notes that you want to leave people on?
I think that's it. You know, I've got probably a few links that I'll send you to like put in the show notes or whatever.
I'll put
you know,
whatever
if
you want in the
anybody's curious
description.
about some further reading or watching, then
Okay.
I can always do that. And people can feel free to reach out to me, you know, either through you or, you know, hit me up. I am, I guess I'm on Twitter, DM Gregg, Gregg at the end, DM as in Michael.
Right on.
And that's also my email address at hey.com. And I think that's pretty much it. You can find Kinsey online. That's KENZIE.academy. Or KinseyAcademy.com. That also works. But KENZIE, named after our CEO's youngest daughter.
Oh, right on.
It's
a cool little fun fact.
Yep. Yeah, check us out. We do good work, and I'm proud of everyone I work with. I'm not. Yeah, we're all passionate over there, and it's we love what we do. And we get graduations every 3 months, which means we hear the stories every 3 months, which is super rewarding and is a really great way to energize yourself multiple times a year.
Yeah, for sure. That's awesome, man. Thanks for coming on the show. Thanks everybody who listens. You can play back what he said for like how you can reach out to him, or you can go through me. Like I said, we communicate literally, multiple times a week. We meet up at least once a week to hang out. So yeah, thanks for being on the show, man. I can't tell you how much I appreciate it.
Thank you. I'll be back.
Yeah. Thanks for listening, everybody. You'll hear us again in a future episode. Have a lovely day, and hope you're all doing great.